Dear all, welcome to the playlist of Sensors and Transducer. You can check the previous video by clicking the I button on the top of the screen. Let us discuss thermistors. So it is one of the application of resistive transducer. Let us understand how does thermistor operate, constructions, practically available thermistors, etc. Moving on to the session. So first and the foremost, we will understand what do you mean by thermistor. So thermistor is a type of resistive transducer whose resistance depending on temperature. And also you can represent the thermistor in this manner. This is a symbol which you can able to represent the thermistor. And also according to international standard symbol, you can able to represent the thermistor in this manner. Similarly, according to American standard, you can represent the thermistor in this way. So we can say that in order to operate thermistor, we require any external excitation. I mean external supply has to be provided for the operation of thermistor. Alone it cannot operate. So thermistor is a passive component and sensing parameter is resistance. So that's a main peculiarity. And also it is made up of certain conducting and semiconducting material. For example, manganese, nickel, cobalt, copper, iron and uranium. There are two varieties of thermistor which is having positive temperature coefficient of resistance and the negative temperature coefficient of resistance. However, negative temperature coefficient of materials are most commonly used. That means the temperature and the resistance both are inversely proportional. And also we can say that the resistance range that is varies in the range of 0.5 ohm to 0.75 mega ohm. Okay, and the temperature you can measure in the range of minus 60 degrees Celsius to 15 degrees Celsius. In US and Japan, you can able to see how they are going to represent the thermistor. You can see the diagram which is given in the bottom side of the slide. Okay, moving on to the discussion. Let us discuss what are the various applications of thermistors. Main application is temperature measurement. Then temperature control, especially in your air conditioning unit, you can use thermistor. And also measurement of power at high frequency, that is another application. Then water flow level, okay, water flow measurement. And water level also can be measured with the help of thermistor. Then you can measure thermal conductivity. Then thermistors are also widely used to as inrush current limiters, especially positive temperature coefficient of resistance material. As I already told you that there are two type of thermistors. First one is negative temperature coefficient of resistance, that is NTC, and a positive temperature coefficient of resistance with the thermistors is also available, PTC. So such kind of PTC can be used as a function of fuse. Then temperature sensors, self-regulating heating elements, etc. We can able to use the applications of, these are the various applications of thermistors. Okay, what are the salient features of thermistor? You can able to read. First one is it is compact, obviously, and the construction is rigid and rugged construction. It is cheap, inexpensive, and regarding the stability, it shows better stability at a high, even higher and lower temperature. And also we can say that it varies inversely with respect to dissipation factor. These are the salient features of thermistor. What are the pros and cons of thermistors? The advantages, they are accurate, true, and it is too durable, lifespan is more, then it is sensitive, cheap, and robust way to measure the temperature. Okay, moving on to the drawbacks. What are the main drawbacks? Thermistors do not work well in extremely hot or cold temperature. It is having certain range, I already mentioned. Beyond that particular range, it cannot be able to operate in a better manner. And curved output, that is another drawbacks of thermistors. But however, it is cheap and the method of measurement also quite simple. You can able to see the varieties of thermistors which is available in the market. NTC 5D11. NTC in the sense negative temperature coefficient. Here temperature and resistance both are inversely proportional. You are measuring temperature in terms of resistance. That's a specialty. Input will be temperature and you are measuring in terms of resistance value. That is why it is known as transducer. Here also you can able to see varieties of thermistors. Here also you can able to see. Okay. Here whatever I am pointing out, that is PTC. PTC in the sense positive temperature coefficient of resistance. So these are the varieties of thermistors which are available in the market. Okay. You can observe the thermistor characteristics. This thermistor is basically NTC type thermistor. Here resistance and temperature both are inversely proportional. So with the help of one equation I can able to represent NTC type thermistor. So RT is equal to R naught times e to the power beta into 1 by T minus 1 by T naught. What is RT? RT is the resistance of the temperature in Kelvin. What is R naught? Resistance of the temperature at 0 temperature. Okay, R naught. T naught is nothing but is a reference temperature. Normally we consider as 25 degrees Celsius. If you want, you can convert Kelvin also. 25 degrees Celsius plus 273. Beta is a constant. Its value is depending on the characteristics of the material. Beta will be directly depending on what type of material you are going to employ. I have given the checklist of material which will be used in the thermistor. The normal value is taken as 4000. The normal value of beta that will be taken as 4000. That is a peculiarity. How do you classify thermistor? As I told you that there are two types of thermistors available, depends on the characteristics. Negative temperature coefficient of thermistor and positive temperature coefficient of thermistor, NTC as well as PTC. In NTC, temperature is inversely proportional to resistance, where in PTC temperature is directly proportional to resistance. That's a speciality. So I have written the same condition over there. In case of NTC, as the temperature increases, resistance decreases. Okay. So temperature and resistance are inversely proportional. However, these type of thermistors are commonly used. In fact, positive temperature coefficient of thermistor has a direct relationship between temperature and resistance. Okay, both are directly proportional. I mean, as the temperature increases, resistance also getting increased. It is not common, rarely it is used, but it is mainly focusing on the protective purpose, protection of the circuit, like a fuse. And both are directly related, temperature and resistance, so it can be used as a fuse. Okay. One more important information, it will act as a current limiting device and application is restricted. However, it can be used, but there are certain constraints, so that application is restricted. I have referred the following textbooks. Finally, thank you very much for watching this video. If you are having any queries, please do put up in the comment box.